Hi everyone, so in this video we are going to be looking at the skill of writing ionic formulae. So sometimes in an exam or a test you might get asked to write the ionic formula for a compound. So this is going to be based on a couple of skills that you hopefully have already mastered, and if not, this is maybe a good opportunity for you to practice these before moving on. But the two skills that we're going to need in order to be able to write an ionic formula is the ability to write a simple chemical formula. So in class we've learned the SVSDF method, which is symbols, valency, swap, divide formula. And that's got to include your group ions, which are things like sulfate and nitrate and hydroxide, these ions that contain more than one atom, and also the transition metals, which usually will be accompanied by a Roman numeral to let you know the charge that they're going to have, or the valency that they've got. The second skill is to work out the charge of an ion. So again, this is a skill that is really important in National 5 chemistry, where you're going to be using the valency and the metal or non-metal status of the atom or ion in question, and also, alternatively, you can use the electron arrangement method for that. Now, either way, these are two skills that we're going to effectively combine together now to make a new skill, which is writing ionic formulae. The ionic formula is written basically the same way that a chemical formula is written. The only difference is that the charge on every ion is shown, and there's a couple of rules that we need to follow when we're doing that. So the first one is up here on the screen already for you, which is that every ionic formula that's written needs to ensure that the total charge of the ionic compound, when all the ions are added together, is always going to be equal to 0. That's really important. The second thing is that any ion, and it doesn't matter whether it's a group ion that we'll have a look at in a minute, or whether it's a simple ion like a chloride or a sodium or nitrogen nitride ion, any ion that we have more than one of in the chemical formula needs to be in brackets. Okay. Now the trick to this one is that the charge of the ion that we've hopefully had practice at doing already will also be written inside the bracket. Now, previously when we were writing chemical formulae, the introduction of group ions kind of takes it up a little level, and for some people makes it a little bit more confusing. There's an extra little step to be involved. The good news is that for an ionic formula, half the work is kind of already done for you, because our group ions, if we remember, are found on page 8. And if I just scroll down just now, I can show you the little table that's found on page 8. You can see here that the charge is actually given to you on that page. So kind of that second skill of being able to write the charge on an ion is already done for you. So all you have to be able to do is to be able to write it in the correct format. So we're going to have a look at a few different examples just now. Once we've done that, I'll give you an opportunity to pause the video and then to have a go at a few examples yourself. Now, to stop this video being too long, I'm not going to go over the SVSDF method in this video. Okay, if you want help or support on that, we can certainly arrange that, and that can be done. And there'll be another video of that method as well. But for now, I'm going to assume that you're able to do the SVSDF method. When it comes to pausing the examples later on, I'll give you two opportunities to pause the video. The first opportunity will be with none of the chemical formulae given to you, and then the second opportunity, if that's something that you're struggling with, so that you can still practice this skill, I'll give you a second opportunity to pause the video where I'll give you all the chemical formulae that you need, and all you're going to have to do is put the ions charges in. Okay, but just to be clear, in a test scenario, in a kind of an exam situation, you would have to be able to go from the chemical name as shown on the screen here to an ionic formula, which is a two-step process. So we'll look at that just now. So lithium chloride is a chemical which has a chemical formula of LiCl Cl. Okay, so LiCl is its chemical formula, so you need to be able to do that using your SVSDF method. And then we look at the charge that's on each ion. So lithium is a group 1 metal. Okay, so the charge on a lithium ion is Li+, and the charge on a chloride ion, group 7, non-metal, valency 1, is Cl-. Okay, so when we're putting that together, because there's only one of each, it's a really straightforward one. It is simply written as Li+, Cl-. Okay, now the second example is magnesium fluoride. Now I've deliberately picked this example because in this example we've introduced our first number. So MgF2 is the chemical formula using your SVSDF method for magnesium fluoride is MgF2. So we look at each ion individually first. Magnesium is group 2 and it's a metal. Valency 2, so will be Mg2+. Fluorine is F-, it's in group 7, same as chlorine, which means it has a valency of 1 and it's a non-metal. But because we have two of them, what we're going to do is we're going to pop that whole ion in brackets and then put our 2 on the outside. So what you should be able to see is that these two formulae that we have written down kind of mirror one another. The only difference is that we've started with our chemical formula, our simple SVSDF method, and then we've introduced the ionic charging. But if we go back up on the screen just a little bit for a second, this rule up here, the ionic charge must be 0. Okay, so the ionic compound, the total charge must be 0. So if we look at our two examples, we've got Li plus Cl minus, so a plus and a minus, they cancel to make 0. In the second example, we have Mg2 plus, and we only have F minus. Now because we've got this in brackets and a 2, we now have two of them. So 1 2 plus and 2 1 minuses, okay, is going to cancel out again to make 0. So in a previous video looking at ionic charge, we used the idea of a seesaw. So on this side we've got 2 plus, and on this side we've got a 1 minus and a 1 minus. Okay, those two 1 minuses add up to make a 2 minus, and therefore our ionic formula is correct. So we've got a little way to check just as we're going through to make sure that we're getting it right. Okay, so the next example is changing it up again just ever so slightly, looking at an example that has a Roman numeral in it. So this one's got a transition metal present, and because the Roman numeral being 2, that's going to come in both when we're doing our chemical formula and when we're doing our ions. So the formula is CuBr2 using our SVSDF method. Okay, we then look at our two ions separately. Copper, okay, with the 2, remember the Roman numeral tells us how many charges it's going to have, that's 2. We know it's a metal, so that's going to be 2 plus. Okay, our bromine is group 7, valency 1, non-metal, so Br minus, and just like in the previous example, we have two of them, so we pop that ion in brackets. Okay, so nice and straightforward. Any time that you've got more than one of any ion at all, we're going to pop it into brackets. Okay, so let's have a look at our next example, which is going to be aluminium oxide. So for aluminium oxide, the chemical formula using SVSDF is Al2O3. So I've deliberately picked this example because there's more than one of both ions. So both the aluminium and the oxygen ions are going to be in brackets in this example. Okay, now this time we're going to look at the individual ions first. So aluminium is in group 3, valency 3, and it's a metal, so it's going to be Al3+. We have two of them, so we're going to pop that in brackets, put our 2. Oxygen is in group 6, valency 2, non-metal, so it's O2-. I'm going to pop that in brackets, and this time we've got 3 of them, so we're going to pop a little 3 down there. And again, if we think about our seesaw, okay, we've got a 3 plus and a 3 plus. We've got 2 of them. That's 6 plus in total on one side of the seesaw. And we've got a 2 minus, 2 minus, 2 minus on the right hand side of the seesaw, which is a total of 6 minus. because those two add up to be the same, that's going to balance out to give us 0, which means that our chemical formula and our ionic formula match and that they're correct. Okay, so the key here, remember, is to have our charge inside the brackets. Okay, so our 3 plus and our 2 minus are inside the brackets, they're not on the outside. Okay, the next example is the first one that's going to be used in page 8 in our data booklet. What you've got to spot is that the ending of that chemical is 8. Okay, so any time that you have anything that ends ATE or ITE, you're going to be looking at page 8. Okay, so we can use the little rhyme that if it ends in 8, it's on page 8. There are a couple of exceptions to that you've got to be a little bit mindful of. There's only 2 that you're going to have to remember. So anything ending 8 or ite, straight to this page. The other 2 are hydroxide and ammonium. Okay, these are both group ions, so they're ions containing more than one atom. One is positive, which is ammonium, which is NH4+. The other is negative, which is OH-, which is hydroxide. Okay, which is really important when we get to our acids and alkali chemistry. Okay, so calcium nitrate is the last example we're going to do. Now again, calcium nitrate, using our SVSDF method, has the chemical formula Ca brackets NO3 close brackets 2. So that's a method that we have to be able to do independent of this question, but now what we have to be able to do is to put the charge in. So we're going to take each ion separately. Now remember, nitrate is one ion. Okay, it's one thing. It just happens to contain nitrogen and 3 oxygens, but it's one group all working together. So calcium, same as before, group 2, valency 2, it's a metal, it's Ca2+. And if you look down here, we don't have any number after it, so we've only got one of them. No need to do anything else with the calcium. The good news is here, we've already got our brackets in place. Okay, NO3 minus, NO3 with a 2. I've just given you a little clue there to what the answer is going to be. If you have a look up here on your data book page 8, nitrate, okay, is NO3 minus. And all you're going to do is literally just copy that over to NO3 minus like that there. Okay, and that's an ionic formula. So this takes a little bit of practice, but it's really just taking 2 skills that we should already have at this point and merging them together to make one type of question. So what we're going to do in a second is we're going to pause the video and we're going to have a go at these examples here. Okay, now I'm going to give you 2 opportunities like I said before. So if you're feeling confident, you want to have a go, the first thing you're going to need for each of these examples is the chemical formula, which is your SVSDF method. Okay, now I'm going to give you a little bit of help here, because what I've done is for the first 2 examples, they're just our simple 2-element compounds. Okay, so it's ide endings, so we're just going to have two different elements present. For example number 3 and number 4, we've introduced our Roman numerals. For number 5 and number 6, I've introduced group ions, so these are going to use page 8 in the data booklet, and I'll include that on the screen in a minute. And then the last 2 are a bit of a free-for-all. I'm not going to give you any help with them just now, no clues, you can have a go. So if you're feeling confident, pause the video now. You can either work through each of them first as SVSDF examples, and then unpause the video, and in a second I'll show you the chemical formulae. Then you can repause the video and then do the ionic formula, or you can work all the way through to an ionic formula, unpause the video and go right to the answers. Okay, so it's up to you. So this is opportunity number 1, okay, for you to pause the video and have a go with absolutely no support whatsoever. Okay, if you're not feeling so confident, this is opportunity number 2 to pause. So what I'm going to do is I'm going to give you the SVSDF answer, if you like, the chemical formula, and all you're going to have to do now is to put the charges in. So magnesium oxide is MgO, lithium sulfide is Li2S, copper chloride, moving the screen about, copper chloride with a Roman numeral 2, copper 2 chloride is CuCl2, iron 3 oxide is Fe2O3, Sodium carbonate is the first of our group ion examples, Na2CO3. CO3 is carbonate, okay, and that's using page 8 in our data booklet. You can see, which is down here just now, which I'll get to in just a second. Magnesium hydroxide is MgOH in brackets 2. Titanium 4 chloride is just TiCl4. And then copper 2 phosphate is Cu3 brackets PO4 close brackets 2. Okay, so quite a bit involved in that one. So if you're now still watching the video at this point, you can now pause the video. This is opportunity number 2 to pause the video. Okay, and what I'll do is I'll just pop down a little bit so that you can see page 8 of the data book in case you don't have yours with you just now. Okay, and you can come back in a minute or two and go through the answers. Okay, so unpausing the video now is time to add in these ionic charges. So magnesium and oxygen. Okay, magnesium is in group 2, and so is valency 2. It's a metal, so it's going to be Mg2+. Oxygen is O2-, group 6, valency 2, non-metal. Okay, tell you what I'll do actually is, just thinking on my feet here, I'll change the pen colour to make it a little bit more obvious. So this is Mg2+, O2-. That's a bit better. The second example is lithium, group 1 metal, valency 1. There's 2 of them, and then an S2-, like that. Okay, 2 pluses, 2 negatives, cancelling out to make 0, always the same. Copper 2 chloride is Cu2+, Roman numeral 2 telling us the number of charges. It's a metal, so it's a 2+. And Cl-, and again, because there's more than one of them, we're going to have brackets. Whenever you have a number, okay, you're going to have brackets involved unless there's a group ion. That means that you have to kind of think a little bit more, which we'll get to in a second. Iron oxide. Iron 3 oxide means it's Fe3+. If you look at the formula, there's 2 of them. It is O2-. We've met that already in this set of examples, and there are 3 of them. Okay, so quite a lot there, quite a lot of brackets and things, but just following the same pattern every time. Okay, so sodium carbonate 5 and 6, remember I did say, are going to be using this data book page here. Okay, so sodium carbonate is Na2CO3, and that's because it contains the carbonate ion, which is CO3 2-. Now, because we've got more than one of the sodiums, it's going to be in brackets. It's group 1, valency 1 metal, 2 of them. Now, this is one of the examples I was saying before, where there is a number, but you've got to remember CO3 is 1 ion, so I don't need to put it in brackets. Now, there is a bit of good news for you. Okay, so that's CO3 2 negative. If you happen to put it in brackets like that, as long as you don't put any number here, which would make it wrong, we would actually ignore those brackets, so you wouldn't actually be penalised. Now, I'm going to get rid of them, just because I'm a bit of a perfectionist. I like it to look right. That's what the formula would be like. Now, the same goes for any example. If I go back to number 1, you could easily put everything in brackets like that. That would still be right. Okay, you're not going to get penalised. So if you're worried about it, pop a bracket around it if you really have to. Okay, but we want to try and be as accurate as we can. Okay, next example, Mg2+. Our brackets are already there. If I look up hydroxide, OH-, pop it in brackets because it's already in brackets, and we put our 2 on the outside. Titanium 4 chloride, now this is one of our unusual ones. We've got a 4+ charge on our titanium, and then chlorine with a negative charge, and 4 of them. And then this last one, okay, it's a biggie. So we've got copper 2+, because it's copper 2, the Roman numeral 2. We've got 3 of them. We've already got our PO4 in brackets and our 2 on the outside. That's not going to change. but we're going to use our data book down here. Phosphate is PO4 3 minus. Okay, and just this last one, just to show what we're saying here, we've got 2 plus and we have 3 of them. That gives us 6 positives in total. We've got a 3 minus and we have 2 of them. We have a 6 minus in total. So that seesaw argument again is going to be completely fine because it's equal on both sides. The total charge on an ionic compound has to always be 0. Okay, so I hope that's helpful. You can obviously go back and rewatch this video as many times as you need to. And if you're looking for some more examples, reach out to your chemistry teacher and I'm sure we'll be able to provide you with some and a bit of practice for you. Okay, have a great day.